Good morning. We're going to talk about security. And we just heard to talk about trade-offs. Trust me, everything is a trade-off, so is security. But the problem is who should make the decisions? And let's get started with this question. DevSecOps. Who of you heard of that word? Who of you likes that word? Exactly 0 people. And there's a reason for that. I get it. Because if you take that word, DevSecOps, and say you put words like blockchain and machine learning next to it, you have full buzzword bingo, in my opinion. When I saw this word, like, yeah, really? Again? We're just making things up? We had developers and operations. We already abbreviated to DevOps. And now we put sec in the middle. What's next? Biz, dev, cloud, op thing? I don't know. Anyway, however, if you think of that, let's focus on the 2 wide parts of this word. Who does DevOps? Who thinks they do DevOps? Who have heard of DevOps? At least you know what it is. Well, think about this way. Are you responsible for creating, or your team is responsible for creating software? Is that true? Yeah? Okay. Are you responsible for putting it into production to a certain extent? And if something goes wrong, do they come back to your team to fix it? Then you basically do DevOps. Because it used to be this way. I develop, works on my machine, now it's your problem. Right? That was easy. But we tear down the wall between developers and operations. We try to glue them together. We got rid of a few people because that's how companies work. And then it's like, we create something, and we also have to put it into production. And basically what you do is dog fooding yourself, is what we call it. You create it, you maintain it, and if something goes wrong, you feel the pain. However, this is not the case with security because it works, right? And look at who uses something like Jira or something like a Scrum board or a Kanban board. Look at all those tickets you have. All of them are feature-based. As a product manager, if I click on this, it does that, right? These kind of situations are there. Nobody says it needs to be fast because that is implicit. Nobody says you have to maintain it or it has to be pretty. Nobody says to you it has to be secure. Oops. But implicitly, we have to do that. The thing is that scalability and maintainability is now a thing. We probably are, for some reason, partially in the cloud. And if it used to be this case, like I would just buy another server and put that in the rack. Well, now you pay by memory usage and CPU usage, so you might want to think about scalability in a certain way that it doesn't only work on your machine, but also if you have 10 million requests a second. Again, security is in the middle because it hits both developers and operations. It is not yet a thing for us. We think feature-based, but we do need to think security-based as well from the get-go. And that's what we're going to talk about. Oh, by the way, this is me. I'm Brian, staff developer advocate. So people ask me, like, what does that mean? I code a little, I email a lot. Let's keep it to that. Java champion, something in the community space. I lead the Netherlands Java user group with a few other people. Blah, 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 not important. Let's get to the important part. What is actually the problem we're trying to solve? Well, let me take you back to my own story from, say, some 15 years ago-ish. Or 17 years ago, because he had 2 years of COVID. Something like that. I worked for the Dutch government. And we deployed our software 3 times a year. That was great. At that point, I could create stuff. And the operation folks took care of that, tested it, pen tested it. And if everything went great, they put it into production. Super. Just before I joined Sneak, the company I work now, I worked for bol.com, which is basically the Dutch competitor of Amazon, and not Amazon Web Services, but the platform, the e-commerce platform. We deployed our services from my team 3 times a day. Good luck with your pen test. Pen test takes days, or if you optimize it, maybe hours. But if I deployed 3 times a day and you did a pen test, you come back to me with a defect, I'm probably already 3 iterations ahead of you. So we might already get hurt. The thing is, we try to deliver software better, faster, and stronger. And faster, there's a reason for that, because we want to take that new feature and put it out in the open before our competitors do. So we have an advantage. Like, okay, sure. The thing is that we're developers. We're creators. We're not breakers. So, hey, the ticket says this. We created a test. It works. Fine. Ship it. We didn't think about security. Security was not really on our mind, but we need to do that. And what we see is that security was just like it was with dev and ops back in the days. There was a silo between that. Dev and ops were separated. From my computer works on my machine, I threw it over the wall. But we see the same with security teams. Security teams are a siloed expertise. So that means there's one security team and 10 engineering teams. And what we do, we hire more engineers. So we have 20 engineering teams, but still one security team. Does that scale? No, it doesn't. Not if we all work together. Because if I just cowboy around, hey, works on my machine, I created a ticket, it does exactly what the ticket says, and the security team comes back to me like, Brian, this is all nice, but no. I can handle that once. I can handle that twice. I cannot handle that 3 times a day. That means we get friction. And if I cowboy around, they get mad at me, my team gets frustrated with the engineering team, and basically we end up in a fight. But what we should take care of is that we should work together, because we do not want to be that company that's getting breached and all our data from all our clients is out in the open. Okay. We're all agreeing on that, right? Let's talk about security. How bad is it actually? Well, if we think about security from our perspective, who of you is a Java developer? Or general developer? Doesn't even matter if you're like, some people are very strong and like, no, I'm a Kotlin developer. Or a Scala developer. Okay, a developer. All of you are developers, great. If you think about security, what is the first part you look at? Your own code. Obviously, because that is the stuff you write every single day. That is great. But think about it, it's just the tip of the iceberg, because it's roughly 10 to 20% of the binary that you put into production. Let's talk about Java. If you create a jar, specifically if you use something like Spring Boot, it might even be less than 10%. However, that 10% is super interesting, because that is the code you wrote. That is the business logic that makes a difference between a general framework and what the program actually does. So yes, we should take care of that. Who of you does code reviews? The rest of you does pair programming? Good. So how do you do code reviews? I've been in this team, and it's like, okay, we've got 20 minutes left before we need to push it to production or demo it to the client. Hey, Junior in my team, 20 minutes should be enough, right? Go review. And then we tick the boxes and we are compliant because somebody reviewed it. Is that the right way to do it? Is that the way it happens? So does code review make sense? Yes. If you give it to the right person. If I took 3 weeks or maybe a month to write it, can I ask somebody to review it in 20 minutes? The defects that come out of that was like, yeah, you should put that curly brace on the next line. Nothing really special, like, yeah, sure, I've got a linter to work with that. So let's create something in Java. I created an endpoint and hope you can read it. What's wrong with it? Let's do a code review. It's an endpoint in Spring Boot. I see it's hard to read because it's part of this. Maybe I can do this. This is the problem. There's a request parameter coming in, and without doing any validation or sanitization, I put it in the response writer. So that means what comes in without checking it, it goes out. Nice. This means I just created my first cross-site scripting attack. Because if I do something like this, oh, this is hard to do, but I hope you can read it. Let's do it like this. I give the user parameter script alert 1/script. What happens then? It pops up an alert, and you would like, okay, that alert, well, how bad is it? Well, maybe I'm able to do something else. Maybe I'm able to hijack your session. Maybe I'm able to read your session ID, send it over to somewhere else, because I now can execute JavaScript. And although most of us dislike JavaScript, it's very useful for these kind of things. Okay, but we did code reviews. So probably we could have found this. And there are more ways of doing cross-site scripting. There are script, mouse overs, image sources, that kind of stuff. We probably have found this if we did a proper code review, correct? Well, let's take another example. I will enlarge it. Watch me. So what I did is I scanned my application for possible problems in my code. And it says already here, like, hey, you have that cross-site scripting issue. Let's see where it is. It's over here. And basically, this means the thing I just showed you. Application, the parameter comes in here, and without any sanitization or validation, it goes out. That means that if I go to this application, and I think it was admin or something like that, because I work at a security company. It wasn't admin. It was admin foobar, which is way, way safer. Anyway, the thing is, if I go here, you see that the word Batman is part of the parameter, and things I can do is, of course, I can do a script, and you see that the script is executed. So it's an actual thing. Normally, you would say, but I have a framework that solves this. Yeah, unless you misconfigure the framework. And I showed that 2 days ago in the workshop I did. This is a thing. But we could have found this without a tool. I am with you on that. But let's go to something else. We have found more crap that I created. I created it, so you can call it crap. It's no worries. What do we have more? I'm looking for this one, yes. Path traversal issue. Okay, let's go to there. It says it started at, let's go to the end goal, to the problem where actually the problem is. All right, here we have it. This is the code. What am I doing here? I basically wanted to upload a file using Spring Boot, so using a form. That comes back to me as a multipart file. This is how it works. But what is this multipart file? It's a plain old Java object, a POJO. But it's a POJO that represents the raw HTTP request. Keep that one in mind. What am I doing? I am taking the file, that original file name, and creating the file, recreating the file in the upload folder. Makes sense. This is what the tutorial told me. But what if my file name, looks something like, and hopefully I can make this work on the screen. File name looks like folder myfile.com or .text. It means that it says upload folder / I'm doing a traversal back out of my application, maybe go into the system instead of the application folders, and override something that has nothing to do with the application. And then hopefully you say, but you run with a user with less privileges, right? Question. Who of you runs on Docker? Okay, what is the default user for a Docker container? Thank you very much, it's root. If you don't set a specific user. So a combination of two issues. Also, I can show, while doing this and inspecting the raw HTTP request by putting up a proxy, I can just flip that metadata of that original file name into something weird, and I can override something else with the binary of a picture or anything. This also means I can override your properties if they are there. I can override maybe system variables or anything else. Something you do not want. What should we been doing? Well, first of all, you could not use the file.get original file name because you don't know what's in it. Otherwise, there are other issues or other ways of solving this. And one of the things it already gives me a hint is look at the canonical path. And that canonical path means let's evaluate that path and see where it comes out. And if that starts with my upload folder, I at least know it doesn't break out of that sandbox. But hey, it worked on my machine, right? Ship it. Wouldn't it be great if we can do this already before we actually hit this to our master branch or to production? I think so. So having knowledge of these kind of things and having tooling available might be helpful. But we talked about our code, and our code was only 10 to 20%. So first thing under the service is open source. And open source, what we mean by that, basically everything you pull in by using Maven or Gradle. You probably look at that and you have a ton of dependencies. Who uses Spring Boot? Yeah. So you probably have like 3 starters, but one starter brings in a gazillion libraries. How many libraries and how many class files are there available in your class path? The actual answer is, I have no freaking clue. But hey, it works. The thing is, 80 to 90% of the code that we put into production is code we borrow from the internet. Oh, how do you look at that code? Stack Overflow told me so. Just put it in, did the trick, it works, right? So, let me take you back to 2017. It's already a long time ago. It was when COVID did not exist and Corona was just beer. There was a problem in a company in the United States. The company was Equifax. Who've heard of Equifax? Well, Equifax is a crediting company. Let's not get into the company because that's not important. What they did is they built their stuff on top of Apache Struts. Apache Struts 2 back in that day. And we can agree or disagree that was a good decision. That doesn't matter. Let's assume that their business logic, that 10 to 20% was A-okay, there was nothing wrong with that. But they used at that point, vulnerable version of Apache Struts 2. People could get in, snoop around for months, and after 76 days, they found out that something was wrong. Oh, detail, the thing was already patched in March of that year, and the breach was in May. Oops. Because we were looking at our Kanban board and what do I need to do next instead of what's running in production. So over 140 million customers were compromised, and so far it cost them like 2.0 billion US dollars, not including any brand damage. So let's get into that hack. Let's get into what actually happened. Basically, they were using an outdated version, but hey, I have an application over here, and that application, hopefully it still runs. If you can see, it runs on Heroku. So, runs on the big bad internet. And what do I need to do now? Well, I'm not going into the browser because if I have to believe all the movies, you don't do this from a browser. No, you do this from a terminal and you put your hood on, right? I can do a request to this application. I don't have to go into this application, but Apache Struts 2 takes care of routing and all that kind of stuff. I can do a curl request using a specific header. And this is the header I'm going to use. It's a content type. You see, it's just a key value pair, content type, and this is actually the content type. Who of you recognizes this content type? Really? Come on. No, I'm kidding. It's an invalid content type. It does not exist. Actually, what happens if you put in a non-existing content type in this specific version of Apache Struts 2, you will go into an exceptional flow. Okay? In that exceptional flow, for some reason, don't ask me why, you are allowed to utilize OGNL, the Object Graph Navigational Language, which is basically the expression language within Apache Struts. And that expression language is great because we can interfere with objects that are already in memory, or even better, I can create new objects. I just spin up a new process builder. I said to this process builder, okay, give me the bash, and I give this bash an arbitrary command. So basically what I say, any terminal command that I do with this header is getting executed, and then I reroute the output stream to an input stream to actually show it on screen. So let's do that. What shall we do? Let's do that one. Let's just try to get the environment variables from my Heroku pod. So what I'm doing here, I'm using that headers.txt I showed you. I do a substitution. Instead of the word command, I put the word envin, and then I do a curl request to local, oh no, not localhost, it's what runs on Heroku. Come on, man. Prepare your stuff. So let's get this one out, and let's get the Heroku machine in. Cool. Ta-da! Environment variables of my Heroku machine. And you would say, like, environment variables, how bad is that? It's not bad, but if I can call the environment variables, depending on the user it runs with, I can create a file. I can create a file, put some content in it, come back tomorrow, execute that script I just created. Good luck with your post-mortem finding out what the heck happened. It's hard. Or even worse, I can create a reverse shell attack because I can execute code on your machine. I can actually say, from your machine, you want to connect to the outside world because you have that capability. And you connect to a server I control. And now I have shell access. So if I can do this arbitrary code executions, that's the most horrible thing you don't want to have in your system. And this is because they were using an outdated version of a library. Just updating to the newer version that had that patch would have solved that all. Didn't cost them like $2.0 billion. Oops. All right, what do we know? Okay, we have the Java home. That's interesting. Let's do something with that. Let's go into that application. Let's sign up. And let's misuse this information. I sign up, my name, my email, password. 1, 2, 3, 4, 5, 6. Because again, I work at a security company. This is a demo. Is this getting recorded? Don't do this at home. Anyway, what can I do? I can create to-dos. I can do a to-do application. I can do something funny like eat pie with a pie sign, put it somewhere in 1970, and well, I'm hungry by now, so give it a high priority. What does the application do? It shows me that pie sign with the ASCII representation. What I know is that the title of this to-do goes to the native to ASCII function that is there natively in the JDK. It's basically I think it is a C file. It's part of the JDK. Cool. Keep that in mind as well. I can also upload files. Oops. I can upload zip files. And what it does is it unzips my file and it puts all the content in my files. Obviously, I am using a library for that because unzipping files in Java is a pain. You have to inspect the byte stream, you have to recreate the file, get the byte stream in. Poof. Is there a library that can fix that for me? Obviously. So let's do this. But what if my zip file, Java home, remember that, /app/.jdk. But if my zip file looks like this, so this is my zip file. Contains 2 files. One, good.txt. Nothing wrong with that, just a plain old text file. You see the second file? It's called .. traverses all the way back to the root of the system, and then goes to /app/.jdk, where I just found out that the JDK is on Heroku, /bin/native to ASCII, because I know the native to ASCII function is used. I'm trying to override it with something that I like. So let's upload this file to my Heroku application, upload file. Where do I have this thing? I buried it way, way back because nobody needs to use this, nobody needs to see this. Exploits. Zip, slip.zip. Cool. Upload it. And what we see in our My Files folder, the good.txt is there. So I know that unzipping took place. Let's create a new to-do. Give it an arbitrary date, it doesn't matter. Priority doesn't matter because now everything comes back as muhahaha gotcha, because I overwrote the native to ASCII file and basically echoing muhaha gotcha, whatever you put in. This is just funny. But you can imagine that if I know a certain function gets executed, I can use this to alter the behavior of your application. So it still looks like it does what it does, but it has side effects. Interesting. How do you think I paid for this trip? Bitcoin miners. Perfect. No, kidding. The thing is, I'm using a library over here to unzip, and if I would look at whatever that library was, you will see that that library is vulnerable. Hopefully this will spin up. Not because I'm logged out. Anyway, it uses the ztzip function that unzips for me, and it has version 1.12. If I would update it to version 1.13, this was all okay because they inspected the canonical path at that point. So keeping track of these vulnerabilities and keeping track of these libraries that you use is important. Say this is your application. Then we know that this is the part of your code. This is your code. We take good care of that code because at least most of you did pair program or code reviews and the rest of you did pair programming. So we at least know that more than one person looked at that code. But how do you care about these dependencies that you pull in? Do you actually look at them? Do you actually update them? When do you update them? Are you free to put in any dependency that you can? Is that library still used? Think about it. Every library that's in your class path can technically be loaded in memory. I worked for one of the major banks in the Netherlands once. I looked at their great monolithic application, looked at the POM file. It had more than, I think, 1,000 lines of dependency things. It had 3 XML marshallers in it. The JDK already has at least 2. Why do we have 3 different XML marshallers in it, and we weren't clear if something was used or not? Well, we can easily find out, but that's a thing. That's also maintenance. That's also things we have to take care of. We have to take care of what we borrow from the internet or from somebody else. We have to take care of that as much as our own code, because my team is not only responsible for this or for my own code, but for the whole shebang. That means that, say I have an application here, it's 222 line. It was 222 line of hideous code because it was a demo application with a lot of duplication. The thing was, it had 5 direct dependencies. Something Spring Framework, something Jackson XML, something AWS SD. How many dependencies do you think I pull in? How many jars do you think you pull in? Just scream. What do you think? And it's not that bad. It was only 54. Okay, now, we all agree that my team is responsible for the whole application. So how many lines of code is my team responsible for? Guess what? It wasn't 222. It was also not 1,000 or 2,222. How many lines of code is my team responsible for? Nobody? 1,000. Thousands? Thousands. Tens of thousands. 460,000 and a bit. And it depends on which version you, of course, you use. The thing is, not every code will get executed, right? Not every path is directly created. But you saw that we could do an intrusion with a weird header and that other thing with the expression language. So I might be able to load these things in memory. You don't know if this code is used. Or do you actually read all the code that you inherit? Maybe. If you're that thorough, I'm like, okay, I'll hire you now. Anyway, the thing is, there are so many possibilities. You do not have a clue which code is used, which code is not used, and which kind of paths are actually possible. And we shouldn't be taking care of that. We should just upgrade to the version that is not vulnerable. So we should take care of that. Because open source use has exploded over the last decade or so. And people that want to do you harm also look at this code because, hey, it's open source. You already give me the blueprint of how things work. New packages get created in ecosystems every single year. This is a little bit outdated, but it gives you already a trajectory how this works. And clearly, NPM is the clear winner with the amount of packages created. And we can debate if that has something to do with quality, but I'm not going into that. What we see is if we look at the different ecosystem, and we took Maven Central as the point for Java to see how many vulnerabilities there are found every single year, there are. And the thing is, it's not only new packages that came in, it's also packages that were in for years, and now like somebody found out and disclosed this thing properly. And I was like, oops, now the whole world is vulnerable. Nice. So we should take care of these kind of things, because what you put in your POM file is not exactly what comes into your application, because Spring Boot Starter Web is just an empty POM file or an empty jar with a POM file, basically, and brings in tons of libraries in. So a framework brings in a library, brings in a library, brings in a library, and it doesn't matter if you use Spring or Quarkus or Micronaut, like, it's just how it works. Most of the problems for both Java and Node are in the transitive dependencies, the things we didn't see, we just use. But maybe they can get executed. And I don't want to find out every single one of them by hand. Where were you on December 10th, 2021? It was a Friday. The day started excellent. I woke up, it was my first day of my vacation. I was actually taking that day off to pack my bags and actually head to a Dutch Caribbean island because due to COVID, that was possible. I was like, okay, yeah, let's do this. Then the Java Champions mailing list, I saw people like Bruno Borges and Martijn Verburg, who work at Microsoft, that there was something with Minecraft. Like, who cares? Turns out it was a logging library. Well, that Friday, packing my bags did not happen, trust me. I was all day researching this, like a log4shell, and I had no clue how important this was or not. Let's try this out. Let's create a hack around this with the information we had in that morning. Because it was disclosed at that point. What we saw is that within the first 72 hours, over 800,000 attacks were done, mostly scripted. That means that it was a Friday, which is nice. Don't deploy on Fridays, right? We had the whole weekend just to create scripts for that. Cool. Over 70,000 packages within Maven Central were compromised because they were using that Log4j library. And we saw with our own customers, about 60% of the folks had Log4j as a transitive dependency and weren't even aware if they didn't scan their stuff that they were vulnerable. We don't know. Look at your scanning results. Oops, yes, we are. So the thing is, who knows how the breach works? Or, okay, 3, 4 people, that's great. The rest of you just updated to the new version, hopefully. Just say yes. Just say yes. Yes, it's getting recorded. Say yes. Cool. So, I'll give you a brief overview. Say I'm having an application and that logs something. Application, and I log something, and say what I'm logging is, for instance, I'm trying to log in with the wrong password. You probably have a log line like, hey, user Brian logs in, login attempt failed. Login attempt 1 failed. Something like that. And you probably print out the username. So let's say that is the case. If I know the username is logged, I can use this weird string to do a JNDI lookup. And what is a JNDI lookup? It's not just looking at something, it's actually retrieving an object. I could, for some reason, combine that with the LDAP protocol. Oh, that's cool. It's not that hard to set up an LDAP server. So let's do that. I own, in this case, evil.com, and I set up an LDAP server that gives me back a reference, and that reference points to a precompiled Java class called evil.class. And it's getting returned into your system. That mayhem. Just easy as that, because depending on how you create that class, if you do something like this, I implement the object factory, and if I implement the object factory, I need to override the getObject instance, and in this case, I'm doing something harmless like opening the calculator. But again, if I can call something like this, I can call anything. Let's try. So, application. This one runs. Oh, that's not the new. Go there. Thank you. Go there. This one runs on a very old version of Java. Java 8, build 1.11. Hopefully you can read this. There. I have my HTTP server and my LDAP server running in this screen. So let's try this. Let's go back and no. Come on. Yes. So log out. Cool. Now I can show you next to each other. So if I put in something like my name, Brian, and put in a password. What we see in, and this is in the bottom of the screen, so I will pull it a bit up. You will see that login attempt for username Brian. So I know that the username is getting printed. Well, in this server, I already showed you that, I put that evil class that I showed you on screen. So I can do something like, hey, connect to my local host in this case, because it's not running on any server, and put in whatever password I want to. If I do this, I sign up, it comes back, and you see that the calculator starts. This could also be done from a remote machine. So that means I can use this to do a reverse shell attack and actually take over your machine and see whatever happens. The thing was that with all the Java versions, and we weren't clear at first, all the Java versions had this JVM parameter, trust URL codebase. And that was set to true. That was the old. So any version, if you look at Java 8, any version below below 191 had that, and almost all Java 11 versions at that point had this parameter set to true, which means something like whatever is happening, whatever is the class is on the other side, I trust it. Not great. So at a certain point in time, the default for the trust URL codebase was set to false. So this won't happen again. So everybody thought, case closed, I'm using a newer Java version, done, right? Not really, because if the class is available in your class path, I can use it to lift it. That means if I have a so-called deserialization string or deserialization gadget chain, because I'm using a library that does, or that has that in it, I can still use that. I have a full demo prepared, but I'm not doing it for the sake of time, where I have Apache Commons 3.1 as a dependency in, and that library tends to have a full deserialization gadget chain, which I can misuse to do arbitrary code executions in Java 17 or something. Super possible if that is there. And think about, if you look at deserialization, the combination of different classes can create such a chain. With the amount of libraries and the amount of classes that are available in your class path, it's just a matter of time that we can create such a chain. It's very hard to find one, unless somebody else did that for me. If you're interested in that, go to a GitHub project called Why So Serial. And they made a bunch of these things public, as in, here, you have a project to already create the payloads for that. Interesting, look at that one. It's for educational purposes only. So, open source maintainers, we asked them how confident are they on their own code, on their own knowledge, on security knowledge. And 63% says, kinda. Okay, we do code reviews and pair programming, and we trust blindly, kinda. It's weird. We also asked them, like, how do you find out about vulnerabilities? And a bunch of them, 27% about said, I probably won't. It depends on what library you depend on. Some of them had to have great groups of maintainers. Some of them is just a single maintainer, so pick it wisely. This is one of the most important questions if I ask my own development team, who is responsible for security? Well, I work at a security company, so it's quite okay. But in most companies, it's like, yeah, works on my machine. I'm a builder, I'm not a breaker. Sure, but if you ask the main population, they believe that we need to work in autonomous teams. I have the decision to solve this problem as fast as possible, but because we know that program manager is breathing down my neck, I want this today. We saw all what Venkat was telling us about. That is a thing. But because we're autonomous, we have to make the right decisions. We have to make the scalable decisions, the maintainable decisions, but also the secure decisions. So at least some of this responsibility falls to us as well. Not saying we have to be foolproof, but it would be silly to think like, hey, it works. Doesn't matter how it works. At least we know what SQL injection is, for instance. We know what cross-site scripting is. We can prevent this. Like, we need to take our fair share and not, for instance, implement libraries or use libraries that have known vulnerabilities. That would be silly. And it's a shared responsibility between developers, the security team, operations folks, and anybody else. And there's we made a distinction between software, which is the binary, and the infrastructure, but in general, it's a shared responsibility. It's not only the security team. That would be easy. It would make my life much more easier. Unfortunately, it's not the case. We should make conscious decisions. We talked about code, we talked about open source, but I already hit you on infrastructure. Let's look at containers. Let's look at Docker containers. What is the first line you do if you write a Docker file? What is in most cases from? Exactly. And what does from do? Pulls a base image. You already feel it? Ouch. So what I did, it was late 2019. I had nothing to do, and I just did a research on the most commonly free downloaded base images from Docker Hub and scanned them for vulnerabilities. This was the result. It was 2019, so it either could get worse or better, doesn't matter. But the thing is that Node was the clear winner. My manager is a Node.js developer, so I rubbed this in his face, like, ha ha. The thing was that if you looked at the image closely, it wasn't Node that was the problem. I just pulled the latest image. The latest image is based on, at that point, a full-fledged Debian Jessie distribution. Do I need a full operating system for my tiny, tiny service? Probably not. So from a scalability perspective, we already say like, hey, maybe you should use a smaller image. Maybe use an Alpine-based image or an Ubuntu-based image, or even build your image yourself. That makes sense because the image comes with full Debian, with all the binaries that comes there, with all the executables that are in there. And these executables might not be directly accessible, but via something else might be part of a chain of attacks, because most of the security breaches are not direct hits. It's not a Log4Shell easy thing that I just showed you. Most of them are a bit more complicated, but are a matter of different problems, different smaller problems individual. They're not that bad, but connected all together, we can make a nice feast. So we should take care of that. We asked people that use the Docker images, like, when do you scan your Docker images for operating system vulnerabilities? And then 50% says we won't. Like, ooh, okay. And how do you find out about new vulnerabilities in deployed containers? I probably won't. That is a bit scary. So let's look into that. What can happen? What is wrong with that? I don't need this anymore. Let's go to this application. I have that same application I showed you back, but now it runs on my local host. It doesn't run on my local host actually just like that. It runs in a Docker container. Let me show you the Docker file. Docker file, and I will enlarge it, no worries. So, cool. This is basically a Docker file. I'm using a Maven 3 OpenJDK build to build my system, and I'm using a multi-stage build. So I built this thing, and then I create my container that goes to production, and that is based on Tomcat, because this was an Apache Struts application. Remember, it's quite old. I need to deploy it in a Tomcat container. So the upper part is just building, and I copy a few things, and then I create my image that goes into production that is based on Tomcat. Tomcat 8.5.21. All fine, right? Well, not really, because 8.5.21 of Tomcat has an arbitrary code execution. So I don't need to touch your application. I just go for your container. Because in this Tomcat distribution, it was possible to upload a JSP file to the server via a specially crafted request. This JSP file could be requested, and any code it contains could be executed. Let's try, because let's go to my favorite database, the exploit database. It was a thing in 2019 already. It's a Python script. Python script that creates that specially crafted request, and it does two things. It creates a JSON a JSP payload to test if it's actually vulnerable, just putting a system println with all A's, just to show if it actually executes. If that is the case, we can do the second step. And the second step is creating same request, but with a form. That form has a text box and a submit button. And every time I click submit, I spin up the runtime, and whatever is in that text box, I put in the runtime. And then I use the buffered reader and put it out in the screen. Basically, what I'm trying to do is I created a very small web terminal for myself. Let's try. So we see that currently this page does not exist, which should be all the A's, and this other page also does not exist. I loaded this script over here, and let's just do this. Check. And you see like, hey, it's vulnerable. Okay, cool. So now, when I go here, we have all A's in my screen, and I didn't touch the application. I just touched the Docker container. This one does not yet exist. Okay, cool, yeah. Second hack, so the second step, that was this one. And it says to me like, uploading web shell. I'm root. So you see, I made a couple of mistakes. The Docker file doesn't have a limited user in it. I should set up a user with limited privileges and then call the application, which made far more sense. And I used a version of Tomcat that is vulnerable because I built it once, it's in production, didn't change the code anymore, so why should I rebuild my application or my Docker container? Well, because Tomcat updated. If I would have scanned this thing, I would have seen that there were a bunch of vulnerabilities, both in my container and my application, of course, but it also would show me this. Like, hey, and this is on my local machine. You're running on 8.5.21, it has over 700 vulnerabilities. If you did a minor upgrade to 8.5.84, I would end up with 41. If I would do this, just switch out the Docker container and switch out the base image for this one, this vulnerability wouldn't happen. So even if you have an application that is not changed, but you base your image on, for instance, the latest version of the base image, rebuilding that image makes sense without changing the application because you depend on a newer version of that base image. And probably if there's some new patches in, for instance, Debian or whatever operating system that is based on, you already get safer. On the other hand, you should be scanning this and looking at the applications to see what is the problem and have proper knowledge to say, do I have to intervene or not? I'm not saying you have to get to zero. No. Knowledge. Know what you need to do. So, okay. Yes, there we are. So we talked about code, we talked about open source, we talked about containers, and way on the bottom, we call infrastructure as code. Who uses Kubernetes? Who likes YAML? Got you. It's pretty easy if you use Kubernetes files, for instance, or YAML files to configure your Kubernetes, to make mistakes, configuration mistakes. Hey, I need to elevate privileges of this pod because I need to test it, right? Oh, unfortunately, I also shipped this one to production. And now this pod had elevated privileges or is outward facing in production. Something you don't want. Something you don't need. That's just one thing. Configuration problems in these things are the #1 cloud vulnerability. So we should scan that as well, as in, hey, there are easy scanners to look at that and say, like, maybe you don't want this. Or you say, yes, I do. Ignore. Super fine, if you're conscious about that. But it can trigger you to say, like, maybe I shouldn't give this one elevated privileges. Maybe this pod shouldn't be outward facing, or worse. So that is totally on the layer below. And why? All of this is now part of the repository that your team is maintaining. It's not just your code anymore. It's also your environment. It's also your infrastructure. All of it is code, and all of it can be a risk factor without touching even the other ones. You saw that with the container. They didn't touch the application. So what is the solution? Basically, the solution is 3 things. Yes, I work for a security company, and yes, we sell tooling. Is that the solution? No. Huh? What are you doing here? Well, it starts with culture. We have to look at each other. Like, we work with different people in a team, and we have different KPIs and different things we care about. As a developer, I care about creating things, putting things into production, making it work, preferably using nice new features and nice new frameworks that nobody uses because that makes my life fun. Right? You recognize that? I see people like, hey, yes, I do that. Like, of course, I need full Micronaut to read an Excel file. Why not? Because I didn't experiment with Micronaut yet, so that's why I chose that. A lot of these applications become that way. Being autonomous has its perks. Anyway, the thing is, we think about different things. Operations folks or DevOps engineers think about, hey, how can I scale this? If there are more requests than we can handle, is it automatically scaling up and down or not? What happened if it goes down at 3 in the morning? Do I need to get out of bed, or does it rescale and auto initialize again? These kind of things. What do managers think about? Top-level managers, I mean. Is it running? Sure. I think they think about deliverables and money. And being better and better, faster and stronger and delivering faster makes money, but you cut corners. You know that manager that's breathing down your neck every single day, or at least at mine, take that feature. I can say yes, and I can do that. But I probably cut corners somewhere. And we increase technical debt. That creates bugs in the end, or the capability of innovating. It's not what we want, because eventually that also gives me lock-in on certain libraries, for instance, because I cannot update anymore, which makes me vulnerable again. Think about it from the same perspective between you and your security team. If you just do something, what do you think your security team is like? Either angry or crying. And both is not a good thing. So we need to play along. We ask our manager to give us more slack on getting rid of technical debt, and we have to make conscious decision that I'm not just pulling in a library from the internet because, hey, if it works on my machine, it's okay. No, make a conscious decision. So playing along and recognizing that we are also part of the solution. We don't have to do anything, but to get the easy parts out. That's already a first step. Secondly is process. Process means don't create new process, because nobody accepts that. Unless you're getting breached, unless you're fully hacked. I was that once, not fun. Then everything changes. Then you need to fill in timesheets, Excel sheets like, did you test this? That works for 2 weeks, trust me, because after that it's business as usual. Thing is, look at how you develop now. What are the things you're doing now? And how can we be better at that and at helping each other and grabbing tooling that fits your process? So I already mentioned tooling. Tooling is one thing, but if it's a tool that runs in the CI pipeline just there, and if all tests are green and automatically deploys, I will be the first engineer who will say, it's like, how can I circumvent that tool and deploy anyway? Because at 3 in the morning, I don't care about security. Because if my customers in Singapore need this, I just deploy it. Trust me, because that is the biggest fear. Thing is, if you just need to tick boxes and all tests are green and you're forced to use a tool in such a way, adoption will not be there. So you need to pick the tooling that fits your process instead of changing the process to fit the tooling. Of course, we have tools. Sneak code to look at your code in the IDE and in your UI, by connect to your Git repository. For your open source libraries, we can check and see if there are vulnerabilities there and maybe upgrade to the newer version. Which one do you need to upgrade to? Same for your container and base images and which kind of binaries you pull in. And of course, the infrastructure is code. This was the sales pitch part. No, I'm kidding. Because we do have tooling, but it doesn't matter if you use my tools or any other tools. Just use the tools that fit your process. Then you hear a lot of shift left. This is nice. It means shift left in this diagram. Shift left means you need to start with this on the machine of the developer, which makes sense. I already showed you something in my IDE. When I'm coding, I already get feedback, just like I do with my unit test, if there's a problem, and I can fix it right away. Cool. But you also need to do it in the other steps. For instance, if I push to my Git repository, every pull request that comes in, I want to get better, not worse. Then you might have a CI pipeline. Absolutely good to do something like that. Then you have to think for yourself, do you want to block your pipeline there? I am not a fan of blocking. We should make conscious decisions. Blocking is, you need to align with these ticks again. Maybe there is a reason why I go to production with a vulnerability. Maybe I am satisfied with this. Maybe I'm way cool with that. But the step after that is, in many times, forgotten. If you are in production, you still need to monitor it. Because we saw what happened with Equifax. For instance, what we can do is look at, Sneak Monitor does that, but what we can do is look at your dependency tree, because that is static when you have that binary in production. Take a snapshot. Look at that over and over again. Every day we just scan it, and if there's something new up, like a new vulnerability or a new fix maybe, we just ping you actively, like, hey, this is going on. Then you can still decide to leave it there or to do something with it, but at least you know what's happening. Same holds, for instance, for your container-based image, because that is static. Your code is already scanned. We can do that in production, but it's also static, but we already know of that. But things in dependencies can change, because Log4Shell was created, that problem was created in 2013. Oops. It was in there until 2021. Great. So things that might work there can be found way, way later. But shift left, I hate that word because we don't work in a waterfall model. We work agile, I just heard. It's a continuous process. Software development, most of the time, there's no end to it. So we need to do it in every phase of the way. On your local machine, when your code and when your application lives on your repository in a CI pipeline, do it in every single way, because that's the same way you probably use integration and unit tests on your local machine, but also in your CI pipeline, to catch it early and often. And it's a continuous process. So security should be part of that continuous process. So it's not just blocking people, but giving them the right tooling, the right process, and doing it in the right way, every step of the way, to catch it early and often. And not just only left, because I don't see a left over here. Anyway, that was what I had to tell you. Hope it was useful. Thank you for being here. Cheers. Obviously, if there are any questions, feel free to ask them now. Come back to me later. You saw my Twitter handle somewhere. No, not here. Let me put the first slide on. Feel free to spam me on there if you want to, or not. I hope you just enjoyed it. And I think there's a coffee break now. So thanks. Cheers.